Measuring and recording time represents one of the oldest scientific activities undertaken by early civilizations. The story begins with ancient people positioning huge stones to greet the rising sun at solstice. This story flows through thousands of years of discovery and invention, leaving us with the precision electronic timekeepers we use today. The passage of time is revealed in the natural cycles around us. The tides, the phases of the moon, sunrise and sunset come and go with a natural rhythm. Incredibly, the human mind recognized these cycles and created instruments to measure and record time. The earliest people marked the important sunrise of solstice with standing stones. As knowledge spread, temples appeared on the landscape. Stonehenge, created over 3,000 years ago, is in fact an ancient timekeeper. Its huge pillars of stone carefully placed to record and predict the rising and setting of the sun, moon, and stars. The flowing sand of an hourglass or the moving shadow on a sundial represent knowledge descended from the ancient timekeepers of the earliest people.
Before the invention of clocks and watches, sundials were used to tell time. In fact, sundials were used in Egypt more than 3,500 years ago.
They consisted of a simple stick pushed into the ground which cast a shadow onto a dial.
To mark the passing of the hours, sundial faces were divided into equal parts. The earliest surviving sundial with hour markings date back 1,500 years before the present era. Some of these sundials used tall stone obelisk to serve as a center stick, or gnomon. Still, there was no standard number of markings, so the length of an hour was not the same on every sundial.
As sundials became more common, the gnomon became shorter and eventually pointed to the north, rather than straight up. When the length of a day was officially standardized at 12 hours, sundial faces were divided into 12 equal parts. These 12 parts marked the hours from sunrise to sunset. This sundial is a typical example. It is made to sit flat and has a gnomon that, when properly installed, points to what astronomers call the North Celestial Pole, the point in the sky directly above the Earth's North Pole. This sundial was made over 100 years ago for a Member of Parliament, W. Patterson, who lived in Ottawa and later became a senator. The dial was designed by Otto Klotz, an astronomer who worked at the Dominion Observatory. This sundial, made by Pritchard and Andrews, a company from Ottawa, can read to an accuracy of 5 minutes. There are an amazing number of different sundial types. People built sundials to sit flat on the ground, fit flat against walls, or even to be portable like this tiny ring dial. To use this sundial, you need to hold it vertically so that it is pointing towards the north. Sunlight passes through a tiny hole in the side, shining on a scale printed inside the ring to mark the time.
I'm going to show you the accuracy of the sundial at Konark Sun Temple in India, built in 1250 AD. People still use it today to tell time. Let me show you a short clip of a tour guide figuring out the time, and then I will explain how the sundial works.
39 12 होने के लिए 39 मिनट्स बाकी है मतलब 19 minutes. Yes. What is the time?
As you can see, the sundial is pretty accurate and people are amazed by it. Let's take a closer look and see how it works. The sundial has 8 major spokes that divide 24 hours into 8 equal parts, which means that the time between 2 major spokes is 3 hours. There are 8 minor spokes as well. Each minor spoke runs exactly in the middle of 2 major spokes. This means that the minor spoke divides 3 hours in half, so the time between a major spoke and a minor spoke is an hour and a half or 90 minutes. Now, at the edge of the wheel, you can see a lot of beads. If you observe carefully, you can see that there are 30 beads between a minor and a major spoke. So the 90 minutes are further divided by 30 beads. This means that each bead carries a value of 3 minutes. The beads are large enough so you can also see if the shadow falls in the center of the bead or on one of the ends of the bead. This way we can further calculate time accurately to the minute. The sundial shows time in an anti-clockwise fashion. At the top, the major spoke stands for midnight, and this spoke stands for 3 a.m., and this one for 6 a.m., and so on. When I place a finger or a pen at the tail of the animal in the axle, the shadow will fall on the edge of the wheel. Now, I simply note the bead where the shadow falls. Using the math we did before, I can easily tell the current time precisely down to the minute. Imagine how much time and coordination would have happened between the astronomers, engineers, and sculptors to create something like this 750 years ago. If you're observing closely, you would have 2 questions in your mind right now. The first question would be, what happens when the sun moves from east to west? Since the wheel is carved on a wall, the sun would not shine on this wheel at all. How can we tell time in the afternoons? Now, the Konark Temple has another wheel or sundial located on the west side of the temple as well. You can just use the other sundial that'll work perfectly from afternoon until sunset. This is the second and the most interesting question. How do you tell time after sunset? There would be no sun and hence no shadows from sunset till the next morning's sunrise. After all, we have 2 sundials in the temple which work only when the sun shines. To this question, I want to point out that the Konark Temple does not just have 2 wheels like this. The temple has a total of 24 wheels, all accurately carved, just like the sundials. Have you heard of the moon dial? Do you know that the moon dials can work just like the sundials during nighttime?
है